Hello, good morning, everyone. My name is Nathan Berger, and today I'm going to be presenting a GIS implementation plan for a new GIS program. It's for a heating and air company called Williams Heat, Air, and Refrigeration Incorporated. This is actually a family business that is really closely related to my family with my in-laws. My cousin Joe and his father started this company a while back, and they've been doing it ever since he was young. And they service the Northeast Georgia area and Habersham and surrounding counties. Currently, they do not use a GIS program to do their day-to-day operations. And I thought this would be a great project to show them how we would implement a GIS program into their business and why it would be useful for their services. They also have a lot of things that they outlined as requirements for the reasons why they need a GIS program. So it kind of fit to implement this project for what they have going on there at their business. So I'd like to go ahead and get started. Requirements. So after speaking with Joe and the management there at Williams Incorporated, as of right now, it's an HVAC service company, and they do not currently use GIS. So they have no way of routing service calls to field technicians. The office manager takes phone calls from customers and then calls the field technicians while they're out driving and tells them essentially where to go for the next job. It's kind of hectic because there's not a software system or map that shows where the active calls are and how they service those calls to each technician. So essentially they just use someone sitting in an office to make multiple phone calls throughout the day to update the status of calls to technicians to go install HVAC units, furnace repairs, duct work, that sort of thing. So immediately right off the bat, this GIS program would offer, uh, some solutions to some of the requirements that they outlined. So they currently do not have a GIS mapping system that locates the location of the service call. So it would be the address of the customer who needs their AC unit repaired. And then that routing service would geocode the location of that address and then assign it to a technician in that zone to then go to the house and do the residential repair work for that HVAC unit. So the main requirement would be routing services. So there would be a need to geocode addresses of customers, know where the location of the technicians are with their vehicles, which would be the AVL GPS location of each car, and then the geocoding of the call, and then routing the technician to the location to service the job. As of right now, they would just pull out their phone and type the address in Google Maps, and then it would take them to the call location. But that seems very a lot of manual labor where we could automate this process with the use of this GIS program. Also, the company stated they typically will go service high priority calls first. So a technician may get a list of 10 service jobs to do that day, but maybe only two of them are high priority, such as, hey, my the furnace on my HVAC went out, I have no heat in my house, and it's 10 degrees outside. That would be considered a high priority call. Well, they have no way to sort their current call list to go out and do services. So they need some kind of application that will prioritize active current calls and new calls coming in to each technician and then assigning them based on a call priority. So that was a requirement outlined. They also want to utilize a customer relationship management type of software, which is more marketing software. However, we can add fields to the data, such as the customer's name. Obviously, we need their address, but their phone number, email, contact information, but personal notes about the customer. So whenever they service a job there, they can annotate. I went to Billy's house to install his AC unit, and he was telling us how excited he is that his kids are going to the University of Georgia. Well, they want to annotate that in the database. So the next time they go out and service Billy's AC unit, they can ask him how his kids are doing at UGA. It creates a personal relationship with the customers. And they currently do not have a system in place that does that. And then also they need a web-based application such as a GeoForm would be my recommendation, where a customer can fill out a web fillable form, and then that service call immediately goes into the database and shows up real time on their operation dashboard. Currently, everything they do is call based. So they do have a website, but the customers have to call the office manager to schedule a service. There's no web form they can just fill out that says, hey, I'm so and so, I live here in Northeast Georgia, and I need my AC unit fixed, and then submit. That currently does not exist. Also, technicians do not have any mobile GIS capability. Therefore, having ArcGIS field map, something that they can see the calls on a map that they are tasked with for that day, and as they're updating real time on a tablet, and then also that routing feature on the tablet to take them from call to call. And all of this would be built into the GIS program. So we've outlined a lot of the requirements. There's a lot going on here for this program. So the main deliverables, what are they looking for if we were to implement this GIS program for Williams Heating Air Incorporated? Well, they need a web-based operations dashboard. They need a web map that shows the active calls, that routes each technician to each call, sorts by priority, and is updated real time. That way they're not having to call the office manager's not having to call technicians constantly throughout the day to figure out where their service calls are going to be. Also, mobile GIS routing and service calls. So we talked about mobile GIS with a tablet. So if we have the AVLs from the work vehicles that the technicians are driving, we can have those displayed on the web map, and then we can have it geocoded to the call. So when their vehicle arrives within 50 meters of the call location, it'll update the status of that call to en route to call as in progress, meaning they're on site. This is very common with like Lyft and Uber applications when a driver drives to the call location and it says, hey, your driver's here now. So having a mobile GIS, also the ability for technicians to update the status of a call on scene. So if they complete a call, say they install a new HVAC unit at a residence, they can pull their tablet out, take a picture of the work they did, add that to the call feature layer, and then update the status saying complete, and then they can route for payment. Other deliverables, we talked about the GeoForm already, and the biggest one here would be the new enterprise geodatabase. Currently, their database does not have any spatial data, so we would have to build out the spatial database for address with the geocoder, network data set for routing technicians to and from the call location, and some other information as well, like assigning employees, zone IDs, vehicle IDs, a lot of spatial relationships that will be involved here for their database. Also adding the customer information, which they have customer information, names, addresses, but they don't have the personal notes that were talked about. And then also adding maybe zip code and county information, so they can start looking at which areas they're servicing the most frequently. And then one of the biggest pieces is training on this new GIS program. Most of their employees aren't going to know how to operate a mobile GIS program on a tablet. The office manager is not going to know how to manage a operational dashboard. It's a web GIS application. So as standard operating procedures for these new deliverables and training material on how to use them is going to be critical to implement this program. We can't just build it, ship it, and hand it to them. We have to walk them through it, and we have to do weeks and weeks of training and practice so they get comfortable with using the software. Data sources required for this project. We talked about we're going to need a customer database, which they already have, but we're going to add things to it. That spatial layer, and it's the addresses for the geocoding, and then also service zones. So we can assign, 2 or 3 field technicians to a zone. So say they're frequently working the east side of Habersham County, well, that might be zone A, and then we'll have zone B, and they will frequently be assigned those zones, so they're going to be in area for faster routing to service call locations. Obviously, we need the AVLs for the work vehicles, so we can see where the vehicles are on the web map, so we can track this, how far they are from each call, and then whether they're in their zone or not. Geolocator, we need a service call database. This actually doesn't exist right now. They can't historically look at past calls at customer locations. So if each customer has an account number associated to an address, so what the cool thing with this new geodatabase, it will allow them to look at historical calls at each address, so they can look at previous work that was done by their company, and then see what notes and pictures were taken on those service call dates. That's really helpful when trying to pinpoint insurance claims or seeing if work was completed or not completed. And then also we're going to need a database for the technicians themselves to assign them vehicle IDs and zone IDs, where that's going to be important when we have them doing the routing piece with the AVLs. And then also I added a survey response feature class. So, and I'll get to more of this later on in the presentation, but there will be surveys built in ArcGIS Survey 123 that will ask the staff how they like using this GIS program and how is it working in service to, like, servicing customers, and is it efficient? Is it making things better, essentially? Software requirements. In order to do this, build this GIS program and implement it, we're going to need ArcGIS Pro, definitely an ArcGIS Enterprise license for the HVAC company as an organization license, and that will also include ArcGIS Server and ArcGIS Field Maps. The field maps will be for the mobile applications for the mobile GIS, and I also added some PGY-admin and PostgreSQL. So essentially, the enterprise geodatabase that will be created is going to use PostgreSQL. We use PostGIS, and it will sit on a local server that will then be synced to the ArcGIS server hosted through ArcGIS Enterprise through a data store. And so the data that is constantly being updated in that enterprise geodatabase is, we're going to push with PostgreSQL to that Arc server, to that data store. So all the data will be updated real time. And that's the goal here, is to provide real time data to the field technicians and to the office manager who's having to manage these calls. And then obviously ArcGIS Survey 123 for the feedback and evaluation piece of the implementation process. And then some of the experience builder to build the dashboard with some JavaScript. And then the enterprise network data set, we actually, that will be needed for the service routing of the streets layers to get the technicians routed to each call. So that's the software needed to implement this program. The design, in order to implement it, we need to build out the ERD, which is for the database structure, the mobile GIS, what is involved with that, the web GIS, the wireframes, how we want the styling of all the applications to be, with the topography and cartographic symbology we want to use, and then the themes itself that fit the brand of the company. The colors off the company's website, they tend to be more red, black, and white. So that was the brand theme I stuck with. Depicted to the right is a wireframe. I was using WebGIS. I've outlined the new URL, which is using the company's website /GIS/ops, because this is a operational web map. And in this wireframe, we can see that this map, it will be compatible with field maps. So the technicians can click it, zoom to their call location, update the call. But essentially what it is, it's an operational dashboard. So the office manager can search by call number, can search by zone, which I have those toggle on and off. They can search by the day. So maybe they want to look at active calls today, or maybe they want to look at calls 2 days ago. They can do that. They can filter on and off the work vehicles. You can see depicted right here. They're labeled 1, 2, 3, 4, 5. So that would be an employee ID number, so you know which employee is at which call. And then the calls depicted on the map use a divergent color scheme from yellow to red. Yellow being a low priority call, red being a high priority call. When we talked about the high priority calls being, number one priority for the field technicians. So when they get assigned their calls, they can toggle. Each tablet will toggle a filter, so they can say, "Hey, filter calls by my employee number," and it'll only show calls that that technician has to service. That way, they don't see what everyone else has going on. It makes things a little bit more organized for them to follow. But from the office manager's perspective, this WebGIS allows them to search by zone, address, call number, employee number. Makes it very easy and quick to go to a call location and figure out what's going on if they need to update a call, change a call, add a call. And again, the topography here used is mostly Georgia font, and with the searchable features at the top, it makes the office manager's job very easy as a operational standpoint. So now we're going to switch gears. So mobile GIS is still considered web GIS, but you're mobile. So we would use the field maps, ArcGIS field maps, to allow technicians to open it up on their tablet. Zoom, they're going to be zoomed in on their call location, or they may be driving. It may be routing them to their call, because the routing services piece is huge. So by either having the location of the tablet or the AVL of the car, that's where the routing will be assigned to the nearest call location for that employee. So the geocoding piece is great, because once they get within 50 meters of the call location, the call will update. So instead of en route, it'll say arrived, or in status, in progress. And then technicians can actually update the call on scene. They can update the call location if the location's wrong. They can take pictures of the work completed. They can attach a sketch, such as a floor plan, if they installed any HVAC infrastructure, such as duct work or a furnace, and they can draw it out and upload that as an image file. Any of those notes that we talked about for the customer relationship management piece of personal relationships of the customer, if they're talking about their kids or their job, the technician can make note of that and put it in the notes field and save it while they're on scene, and it'll be saved in that call layer. So that way, when next time they go back to that address, they can look at the notes and go, "Oh, our customer Billy said, his kids were attending University of Georgia, so we should ask them about that," because that builds that personal touch and it shows customers that you care. And this was a huge requirement that was asked when I talked to them about implementing this GIS program, is being able to write personal notes about customers. And I thought it was really cool that they can do that using mobile GIS with their tablets. So that's the main focus of this GIS implementation program, is the operational dashboard and the mobile GIS piece. Here we're still in the design phase, so we got to talk about how the data talks. So the ERD. So the ERD is an entity relationship diagram. And it shows the new enterprise geodatabase that will be created. And what it will do is ingest the old customer data into this new geospatial database. And then it will be synced to Arc server, and then to a data store. And that data store will update every time the enterprise geodatabase updates. So we can, using PostgreSQL, we can actually push that data. You could hourly, every 2 hours. We're actually going to be pushing it every minute to provide that real-time update. So everything should be very quick when calls come in. That way, we can cache the data on the web map, and it won't bog the system down, because we don't have many people. The business isn't a large company. They have less than 10 employees, because it's a very small business. So the stress load on the servers is actually going to be really low. So we can have that data pushed very frequently. And over here on the right, you can see how the ERD is displayed. So we have the service calls table. We have feature class, which has a spatial relationship to the zone and the county. So the call will be within a county, and it will be assigned in that county, but it will be closest to a zone that the business, we're going to create these polygons called zones for the service routing. So, employee 1, 2, and 3 might work zone A, 4, 5, 6 work zone B, etc. And that's how that geocoding will be assigned to the zone in that zone ID. Customers, you can have one customer to many calls, right? Because they may go out and install an AC unit and then have to go back a week later and do something to it. So that's that one to many relationship. And then you could have more than one technician to more than one service call. So you could have two technicians go to the same house or go to multiple houses. There might be a trainee or it's a big job and they need more than one person. So that's the many to many relationship there. But every call will be assigned employee IDs and account IDs to the customer account, and as well as a zone, and then everything else that gets updated by the technician. Every customer, when they request a service call, they have to create an account with the organization with that web form, and that every account is assigned an account ID. And then they have to put in their billing information, their contact information, and it's all displayed there on the ERD to the right. As far as the GPS location for the AVLs, again, the business, the goal would be to have the location of each work van that's driving, or they could do the location of the tablets, whatever is easier. I thought the AVL would be more accurate, the GPS updates. And then that will be assigned, that will come into play with the routing piece with the zones, but each AVL will be assigned to a technician because each employee each field technician will have a work van. So that would say one-to-one relationship. They're not going to have more than one van. So they'll be assigned a vehicle and that's their vehicle. So we talked about the design phase. We're going to go into the construction phase now. So here's where we actually start building some of these things to make this GIS implementation program happen. So we're going to have to set up the license for ArcGIS Enterprise for the company, build out the new geodatabase, launch Arc server and install it. We'll set up that data store, then build out that geoform, the mobile GIS application field maps for the tablets, and then the actual operations dashboard, which will be using a web map and the enterprise, the data store that's on ArcGIS Enterprise Arc server. So to get into the Arc server infrastructure, you have the data server, which then goes to the GIS servers, which then goes up to the web server and the mobile applications. That's just one way. I found that this was cited off of Esri's site. I've seen it done differently in other organizations. For this GIS implementation program, as I already talked about, the Arc server will be installed, and then it will be hosted through ArcGIS Enterprise. And that enterprise geodatabase that's being created will sync to that data store. And it'll be a PostgreSQL open source database that will ingest the current customer data, and then going during the implementation phase will actually be running to production, adding that new customer data as it's going. Then once the construction phase is over, everything's been built, it's time to actually deploy the applications. In order to do that, though, the company first needs to have training videos, SOPs. How do I use this web map, this dashboard? How do I use my tablet? It's routing me to a call. I don't know. How do I update the call? How do I take a picture of the work I done and add it to the call? These are things that the employees need to be walked through and trained on, which means training videos, which means actually working with dummy data and practicing it as if you're out in the field and doing a job with field training. And sending an email out, that's huge. There needs to be an email sent to the whole company saying, hey, we have this new GIS program. This is everything it entails, and we're going to train you guys on how to use it. A lot of companies don't do that. They just go, oh, here's this new URL, go to it. And so that's something that needs to be part of the implementation phase. And then also the evaluation and feedback. So we've given them training, they've given them SOPs, we've gone through videos. Now they're out in the field. These technicians are using these tablets. The office manager and supervisors are monitoring these calls on the dashboard. Okay, well, is it working? Did the GIS team put forth a good GIS program, or is it not working? So that's where the ArcGIS survey piece comes in. So surveys will be built for the employees, also the customers. And that's that customer engagement piece to get the feedback from the employees using the GIS program, and then the customers that are receiving the HVAC services to see, you know, maybe the employees really like the GIS program, but the customer's satisfaction's gone down. Well, then that's not good because that's not the goals and objectives of the business. So we want to make sure we're meeting both customer expectations and the organization's expectations. So that's kind of where those surveys come in. We can launch those surveys during so it would take about 6 months to, and I'll get into that next slide, 6 months to build this out, and then a 12-month implementation timeline. During that implementation timeline, we'll be getting the survey feedback every month and then evaluating how it's going month to month. And then at the end of that 12 months, we can look at profitability of the business, customer satisfaction, work order efficiency. Did work orders go up or down by using this program? And then that helps us gauge whether it was successful or not. Again, 6 months to build this out, 12 months of testing with the implementation phase. Requirements are essentially 90% complete. Creating the new geo database, 25%. Some of these beginner things don't take very long, but then when you start getting into the actual application design and development, that's where it gets more complicated. So it would essentially take 6 months to build everything out, assuming the business doesn't change anything that's currently been talked about, and then 12 months of testing. Now, if the GIS program is very successful after launch, when it goes to production and everything's been deployed, then that 12 months may not need be necessary, but there needs to be some time period of evaluation feedback from the customers and the GIS users, which are the employees, the field technicians, and the office manager, about using this application. So, but that's kind of the timeline for implementing this GIS program. And that completes my presentation. The cost, the organization license for ArcGIS Enterprise would be, for what they're asking for, would be about $20,000, plus the salary of, or cost of, the GIS team to build this out and then do routine updates and maintenance. So initially, that first year would be about $80,000 if they were to pay $60,000 for a full-time GIS analyst, and then maintenance would be about $1,000 a month after that for continuing on. Some of the geocoding and network service routing may add more to those costs, but that enterprise license with ArcGIS Server, that covers the whole organization and everything caked into ArcGIS Enterprise. So I think it's a great plan. I think if the business is willing to invest in it, it would definitely increase their operational capability and their mission effectiveness. I do think the profitability is going to go up, and their confusion between the field technicians and their office manager is greatly going to decrease, which should also decrease a lot of confusion for their customers. They do great quality work, and the whole point of this GIS program is to allow them to focus more on the work instead of having to handle all of this operational mission stuff that's going on between assigning a call, knowing where the call is, getting to the call, updating the call. These are things that they shouldn't have to worry about. That's where the GIS program is automating a lot of this workflow so they can get to the residents in a timely manner and install the HVAC unit or fix the problem, and then have that personal touch with the customer to let them know that they remember who they are and they care about them. So that concludes my presentation. Thank you so much for your time, and I hope you have a good day.